Hello, welcome to Meki Teki. Learn as engineer, teach as champion. I would like to thank my family for their continuous support and encouragement for creating me these kinds of technical videos in public domain. And I would like to thank my mentor, Professor R. Surendran from Government College of Technology, Coimbatore, for igniting me a spark of creating these kinds of technical videos in public domain. And I would like to thank Almighty my God for my good health and broad mind. And I would like to thank my friends, followers, my dear students and subscribers for their continuous support and encouragement. Today's topic of interest is milling. We know that in milling, multi-point cutting tool is being used and it is a metal machining operation. Milling is a metal machining operation where multi-point cutting tool is being used, and this is a one type of oblique cutting. Whether you can say vertical milling or horizontal milling or up milling or down milling, all the things in every cases we can say this is an oblique cutting, which means the tool path is at an acute angle to the work axis. So that is the thing. Okay, so with this information I would like to start the milling with the two types of a milling process. One is up milling and down milling. I would like to clear this thing. So in up milling or down milling, the direction of the cutter and feed is very important. Let us say the feed of the workpiece from right hand side to left hand side, where the cutter, if it is an up milling process, the chip flow is in upward direction. Therefore the milling cutting tool should rotate in anti-clockwise direction. In down milling, the cut chip will be in the horizontal direction and the cutter rotates in clockwise direction. Clockwise direction. If you can see here, the feed and the cutter motion are in opposite direction. In up milling, in down milling, both are in same direction. Okay, so this is the information about the up milling and down milling. And the up milling is also called as a conventional milling, and down milling is also called as an climb milling. So this is the other name of up and down millings. So here I would like to give an elaborate thing, that down milling or climb milling, up or conventional milling. Here you can see the direction of cutting force. The direction of cutting force. So here you can see the direction of the cutting force, and uh, the way it is getting cutted have been mentioned here. In upmilling, a thin cut at the entry of the tool, very thin chip is being formed, and the thin chip is getting increased to the maximum extent. So here you can see the maximum thickness of the chip can be removed from the work material. Whereas in the down milling process, the entry it is maximum. The chip thickness is maximum at the entry, and at the exit there is zero thickness or minimum thickness. Here you can see the cutting force. In down milling it is in downward direction, in up milling it is in upward direction, which means in down milling the work clamping force is not highly required. A very simple clamping is required for down milling, whereas for the up milling a huge clamping force should be needed. And also here the at the end we get a minimum or a zero chip thickness. Therefore it can produce very good surface finish, whereas it won't produce it won't produce a very good surface finish in up milling. So we are going to discuss about the milling process and the difference of up milling and down milling process in forthcoming slides. Let us see. As I said earlier, the milling cutter is mounted in arbor. So this is very important. The milling cutter is mounted in arbor and multi-point cutting tool is being used and the oblique cutting action is being taken place. Here, up milling is also called as a conventional milling and down milling is also called as a climb milling. And here I would like to give some of the comparison or difference between the up milling and down milling. In up milling, workpiece is feed opposite to the cutter and a tangential velocity will occur. And in down milling, workpiece feed in the same direction as that the cutter rotates. And the second point in up milling is improper surface finish will getting, and in the down milling we will get good surface finish. In upmilling, initially chip thickness is low, at the end the chip thickness will be high, whereas in downmilling, initially chip thickness will be high, at the end the chip thickness will be low. In upmilling, does not provide longer tool life. In downmilling, it provides longer tool life. So this point is very important. So this point is very important. So this I will come at later. Next, in upmilling, the chip more clamping force is required, whereas in the downmilling, less clamping force is required. In upmilling, more tool wear occurs. In downmilling, less tool wear occurs. And upmilling, less material removal rate. In downmilling, more material removal rate. And upmilling, less efficiency. In downmilling, it is having more efficiency. So the point I have marked, without this point, we can say the down milling is very good than up milling, but this point is very important point, because why I am saying this is the backlash does not occur at up milling. In down milling, backlash occurs. Therefore, only new machines only can be used for down milling process, whereas up milling, any machine, new or old, irrespective of machines, we can use. If the backlash is occurs, it will generate high maintenance problem, as well as to work machine life will get decreased. Once the machine life will get decreased, all the other advantages all the other advantages will be converted as an disadvantages. That is why the only new machines only using the down milling operations. In all the other machines which we have seen in day-to-day life of the milling process, all are an up milling process only. Down milling process is very minimum, or it can be used in only a new machines because of this backlash. Next, I would like to give a classification. In classification, column and knee type, in that horizontal milling machine, vertical milling machine, universal milling machine, and omniversal milling machines are very important. In column and knee type, in the horizontal milling machine, cutter axis is parallel to workpiece surface. Cutter axis is parallel to workpiece surface. So the images are in the down slide. So we will see the how the horizontal and the vertical milling machines are happen. The vertical milling machine, cutter axis is perpendicular to the work surface. In universal milling machine, table can be swiveled to and enables helical grooves can be milled. Vertical, horizontal, and territory can be possible. Territory means the next direction can be possible. In omniversal, additional movement of the table can be tilted vertically only. Vertical tilting can be applied on the omniversal milling machine. So here it is a simple thing of a horizontal milling machine where this is an arbor support. This is the spindle. The spindle only the milling cutter is being mounted. So the spindle is called as an arbor. Okay, so this is a horizontal milling machine, and here we can get a overhanging arm. This is the control panel, and this is a table. So table can be moved this and this way, horizontal position, vertical position. So if it is both horizontal vertical, so this is called as an horizontal milling machine. If it can possible to tilt in this direction, it is called as an omniversal, or in this direction too, this is called as an universal. So here this is the table is mounted on knee, so this is called as a knee. Table is mounted on knee, and this is called as an column, and a table transverse direction, and base is there. For every machine the base should be there. So here the important parts are base, knee, column, spindle, overhanging arm, table, arbor, and arbor support. So these are all the very important parts in the milling machine. So with these machines, these parts are very important. These parts will give or reproduce the accuracy or precision of the metal cutting. And next one is the vertical milling machine. Here the spindle axis is vertical. The spindle axis is vertical. So end milling or other type of a milling is being happen. So here also we can say where the important parts like base, knee, column. Here we can say the ram. We can say the ram. So the cutting tool will have a depth like this, table will have a movement like this, and table is also having an upward motion like this. Okay, here is the control panel, cross feed is there, table feed is there. Here the tool is mounted at the spindle. So like that the vertical milling machine can has been postulated here. So with this, I would like to close the today's session. I hope that I have given an enough knowledge about the milling process. So if you have any doubt, please let me know in the comment section, and I will put definitely another video for your betterment of understanding. So with this, I would like to thank you all, and we will meet in the next video. Until bye bye from Santhosh. Thank you.